Okay. You guys can see my screen now, right?
Yes, we can see it.
Okay. Now, what we're gonna do is today, inshallah, hopefully, we have the last lecture on software architecture, and we'll try to inshallah finish this today. Probably, as happened in my previous section, probably I'll reduce one example. I'll bring one example on Sunday for you guys as well, but I'll talk about that as we move there. But in a nutshell, we're going to try and finish the architectural concepts or architecture part of the course today. So far, what we have done is we have looked at the concept of architecture, we defined it, and then we looked at some basic architecture styles ranging from client server to pipe filters to blackboard, interpreter, peer-to-peer, event-based, publisher subscriber, right? So we looked at those ones. Then, as an example, we looked at the Napster, we looked at the Gontela, just to understand, and we also looked at the Skype, where basically we were trying to understand that how either you can use a specific style directly, like in case of Gontela, you use P2P, or you can use combinations of them, like in Napster, you combine client server with P2P, or even in Skype, you were combining client server with P2P, style. So I think we talked about this, but just I think we stopped somewhere here as well. So we're just about to finalize this discussion. So I can finalize this with the help of a bit of these bullet points here, which is all about that. It's a mixture of client server. So Skype, then this is the original Skype, right? So Skype is a mixture of client server and P2P architectural style. And basically, what happens here is that there was an issue in Napster, if you recall, that you had a one single point of failure, which was the content directory. And Skype, what they did is they allowed replication and distribution of the directories in forms of supernodes. So they had the supernodes, and they used these supernodes to replicate and distribute this directory information. And as a result, they overcome the issue of scalability and robustness, which was being faced by the Napster, right? So basically, these supernodes are containing the directories, and then they are also replicated and distributed. And as a result, this failure, one single point of failure is reduced. Of course, these supernodes are ordinary nodes or ordinary peers, and they are promoted to supernodes, and they are done based on network and processing capability, and so on and so forth. How exactly it was happening, what's inside it? Remember, Skype is not an open source protocol, so basically, it is a proprietary one, and there is a bit of information which is available. Not all information is available, but we know that as part of their algorithm, they used to monitor the network and the bandwidths of these supernodes, and as a result, they used to promote them. Moving forward, since it's a proprietary protocol, as I remember, someone asked the other day that what happens to security? Can we make security into Gontela or Napster? So because here it's a proprietary protocol, and their focus was on making calls and protection of the privacy. So they did include encryption as part of their protocol, and this encryption basically was providing the privacy for calls that were relaying through the supernode intermediates. So basically, these calls were all encrypted, and basically privacy was being protected. Of course, again, they wanted to avoid malicious activity in the network. They don't want people to just come and start sharing or distributing, malicious files in the network as it was very easy in Napster or Gontela. So basically, you have to register yourself as a client into the Skype. You will have your own Skype application on the client side. And of course, this is how they were preventing the malicious clients from entering the network. So this is something we were talking about the other day on Tuesday. Any questions on this before we move on?
Doctor,
Go ahead, please.
Is the the quality or the how I don't know how the video quality will be in the call is affecting our design?
Okay. So in other words, if
Like
I
for example, the protocol we use, we will use a private cable from internet service provider or not, or something like this.
Okay, so if I understand your question, basically we're saying that as an architect, as a software architect, do I have to consider, for example, that since it's going to be a video call based, sharing, what kind of protocol should I be using? How I will be encrypting it? Is this correct, right? This is the question, right?
Yeah. Yes.
Yes. Yes, absolutely, absolutely. And this is a key consideration for you as an architect. So if you're developing a system like something like this, and this is where you will be, you'll be making calls about, how this system will work, whether I will have this whole video in one big chunk or whether it will be in smaller units, right? And so on and so forth. Absolutely. Now, if you just bear with me in the next two examples, which are the last two examples on architectures, I'll be showing you guys and one, of course, one example which is coming very shortly is something you guys use it anyway, but there is another one which is the Google file system or Hadoop. Basically, this gives you some out of the box industrial solutions which are out there in the market now. And I'll show you some of those practical examples so that you can realize that, how people, for example, when they have to think about this bandwidth issue plus this huge videos and all of that stuff, how they have tried to solve this issue, inshallah. Just bear with me, inshallah, for a few more minutes. I'll be showing you a bit more examples here. Any other questions on the three examples we have covered so far, the Napster, the Gontela, and the Skype, before I move on? Okay, so everybody seems to be comfortable here. Okay, so let's move on and let's look at another example, which is again, the aim of these examples is just to kind of, help us look at some practical side of these architectures and what are the different issues people are facing and how they came up with solutions to overcome those issues. So let's look at BitTorrent. I'm pretty sure everybody has used BitTorrent at a certain stage, isn't it?
Yes.
Yes. Yeah. Yes.
Yes. A lot, exactly. Okay, so let's see what happens here. So BitTorrent actually, is a very different from other P2P file sharing protocol, right? Because what they did here is that as part of their protocol, they made a change, and they said we will not have any search functionality built into the protocol. It's a key difference. Like, for example, if you recall in Napster, they were using the content directory to search for the content as well. In Gontela, they were using the network, the neighbors to go and search for the files. Here, basically, even for example in Skype, the original Skype, they were using supernodes as a directory. Now here, what they did, they said, okay, we're not going to have the search mechanism built into the BitTorrent protocol. Actually, what we're going to do is they say we're going to use the BitTorrent protocol to actually something which is what it is excellent for. In other words, they said, I'm going to use, or we're going to use the P2P protocol style for what it is good for, what is efficient for. And this style is efficient for sharing content in a very loosely coupled environment and a scalable environment and robust environment. So they said, okay, BitTorrent gonna use a P2P style for actually sharing the content, not using it for searching as well. The question is then, what is the search now, right? So what they did with the search. So what they did is basically now, of course, as I said, BitTorrent does not allow users to share files directly. So they said users will not be able to share file directly as was happening in Napster or as what is happening in Contaila. If you want to share a file, you cannot just say, I want to share a file. No, they said, no, this cannot be done. What you have to do is you have to have a torrent file or you have to create a torrent file. And this torrent file will be used to actually, transfer sessions, a particular file or a files. So far, so good?
Yes.
Yes.
And see how it is different from the other tools?
Yes.
Yes. Now,
Yes. Yeah.
yeah, so let's move on to this bit now. So basically, there is no way of searching for torrent files in the BitTorrent protocol. So from if it is not part of the search of the torrent file is not part of the protocol, then from where you guys get the torrent files then?
I get it from websites.
Exactly.
Like get the file. Like I think this file is the location of it. I think.
Exactly. So basically, they said that instead of the most of the peers downloading these files, basically you download these files from a website, right? So there are certain dedicated websites for torrent files, and they usually host the torrent files. And of course, all users are also allowed to upload their own torrent files there. So this website is 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 taken out of the actual BitTorrent protocol part for the content sharing part, and they moved the search. Again, see, this is a design decision. This is an architectural design decision you're taking, and you move the search away from it so that you can use BitTorrent protocol as a P2P protocol for sharing content. So once a peer has a torrent file, you're allowed to go and use it and join the torrent session by using the BitTorrent application. And once you are in a BitTorrent application, basically you as a peer can be in two different states, one of these two states, uh, or two different states as I said. Either you could be in a leecher state, which basically you're downloading the files, or you could be in an uploading stage where basically you're uploading the pieces for other leechers. I'm pretty sure you guys have seen this. Right? So you
How
download yeah, go ahead, please.
how it's uploading? Isn't it and when like I'm download isn't it like I'm downloading it from a computer or how it
Hmm. So when you say computer, do you mean a server or you mean other
server
peers?
or a beer? I think it's a server more like server, not beer.
Mhm. It is peers. This is where the key point here is. It's a P2P system. So it's not actually, you're not downloading it from a server. You're actually downloading from other peers. All you have you have a BitTorrent file, which is created. So if you want to share a content, a video, you will create a BitTorrent file and you will upload this BitTorrent file to a website which hosts the torrent files only. And that's it. They are not there for downloading the content. No, they are just hosting the file, the torrent file. You get the torrent file. Once you're into a torrent application, the, the, the protocol is P2P. It will go and get the files from other peers in the network. It will that website which is hosting the torrent files, you don't get the actual file from there at all. Is this clear?
Yes, it's clear now.
Yes. So that's why you are, as a peer, you are actually in two states. Either you're leeching, which means you're downloading the file, or of course, because if you are sharing a content, or and I'll explain, there is another possibility. If you have a part of the file which you already have been successfully downloaded, then and someone else needs this, you might be uploading that file to them as well. And I'm pretty sure you guys have seen this. Okay. So let's dig a bit into it. So basically what happens is that a peer is in a seed state. It's what we call a seed state. If it has the complete file and it's uploading to other leechers. So once you have a complete file, you are in a seed state. In other words, in the beginning, for the very first time, for content sharing of a specific exam, specific video or whatever, there will be at least one peer who will be in a seed state because it will have the complete file. And of course, as the sharing will increase in the network, other peers, once they will have the complete file, they will also become seeds as well. So they can also, they can take over as a seed role. So you need at least one seeder, of course, in order for the torrent to be alive. So, if you don't have any seed in your network, this means that nobody can really go on and completely download the file. But you need at least one seeder in the network to be able to, for the leechers to be able to go and finish it. So otherwise, they will not be able to finish it. And of course, this is the strength of their infrastructure and structural architectural style is that, or the way they designed this is that, if the original seed has uploaded every piece, once it has, once this is done, well, that original seed can even leave the network. They can go offline as well, and the system will still survive. The files will still be shared among the network because now the the every piece of that file has at least been uploaded or sorry, has at least been downloaded by by different leechers or peers in the network. And is this point clear so far? What's happening here?
Doctor,
Go ahead, please.
the seed should be online so I can download the file, right?
Yes, the seed has to be online for you
This-
to download the file, but this is the point. This is the strength of their structure, that you need at least one seed. But let's say the file has now, because see, remember another point, but maybe I'll answer this in a minute, because see, the file is not stored as one file as such. Your file is actually distributed into smaller parts. So as long as these smaller parts have been uploaded sorry, as long as these smaller parts have been downloaded by other peers in the network, that's it. You don't need the seed anymore. And of course, once another peer has downloaded the complete file, they will also become seed.
Thank you, Doctor.
So is this clear?
Yes.
Okay. Now, let's look at it. So let's move forward. So this is where the answer will come now, inshallah. See, each file actually is split into equal pieces, and they are further subdivided into smaller blocks. And what is being shared over the network? What's when you see you are in a leecher state and you're downloading something, you are actually downloading these small blocks. So these blocks are the unit of transmission on the network. And the protocol keeps tracks of which pieces have been downloaded. So this is what is happening here, that you don't try to download the whole file in one go because you're talking about the huge files here. So what they did is they said, let's create a torrent file, which will be like a metadata file, which get information about the complete, file you want to share. And then you as a user or as a client, you'd go and download that torrent file into the BitTorrent application. It shows you where this file is available, you start downloading them, and you don't download the complete file in one go. I'm pretty sure you must have seen this as part of the progress bar in the app. You are actually sharing or downloading blocks of it. And the reason they went to the block size, which is a smaller size, is because it's easy to transmit over the network. It consumes less bandwidth, and it's faster and efficient. So as a result, each pair must contain a list of peers it's connected to, and which is called peer sets. Like Contela, where you had information about your neighbors. Here in the protocol, they also keep track of the information about your neighbors as well. So you basically keep track of your peer set, the peers which are connected to you, and you're actually trying to download the files from your peer set first, or if it is not available in your peer set, you ask your next peer sets, and so on and so forth. So these peers, by knowing that which peers can upload, and by knowing what pieces is connected to, BitTorrent can use this information in order to deliver content to you efficiently. And typically it results in a 10th% of the bandwidth overhead, and basically it's quite efficient. So what you're really doing here, to be honest, just if I have to summarize, you have a file, and that file is actually divided into smaller blocks, and these blocks are being uploaded or downloaded by other peers. Okay, and basically, if you are trying to download the specific file, you have your peer sets, which is you are a peer here, and then you have so many other peers, and this is probably one peer which has all the files, and basically it will tell you, oh, okay, this one has it, go on and download it. It will not download the whole lot in one go. It will download block by block. Now once this block has been downloaded, now this block is available to you now. Now others can also start downloading from you as well, and hence, as long as all of this has been done, even if this seeder goes down, no problems, it will still work. Is this clear?
Can you repeat the last point, please?
Okay. Let me come to this, and then I'll try to summarize everything, right? So, and because this will make a lot of sense, and so let's complete this part discussion. BitTorrent it has a centralized server which is called Tracker. Okay, so it also has something called Tracker, and Tracker is responsible for help peer find other peers. It is not responsible. The Tracker is not responsible for actual distribution of the content. It's only responsible for finding the peers. As a result, in a nutshell, BitTorrent is actually a hybrid network which uses client-server architecture and P2P architecture. Now, let me explain this step by step one more time. And I'll start from this slide backwards now, right? So first of all, BitTorrent is a combination of client-server architecture and P2P architecture. Now, what is the role of a client server here? The client server role is that you have something called Tracker. And Tracker is doing what? Tracker is keeping track of other peers. That's it. That's the only role it has. Now, where are the torrent files? Torrent files are not here in this network at all. They are separately stored on a website. So they are completely out of the box here. So they are stored on a website. You do search there, you find there whatever file you're looking for, and you get that torrent file. So once you get that torrent file, now you are in your BitTorrent application. Okay, so you have the file now, you want to now go on and search it. Now what's happening inside this black box, which is your torrent application, you have a tracker, and this tracker is keeping track of the peers you have. And B, there will be different peers in the network. Each peer has its own peer set as well, right? So what's the peer set? Peer set is keeping track of all the peers are there in the network connected to this guy. Okay. Now, how the downloading mechanism works. Let's assume the file you're trying to download is available with this peer, which is your seed. Everybody who is trying to download this file will start downloading from it. And we also know by now that the file you are trying, the actual file, not the torrent file, the actual file you are trying to download from the seeder is not downloaded in one go. It is downloaded into smaller blocks. So you download one block, then you download the second block, then you download the third block. So if you are downloaded the first block, now you have block number 1 available to you, correct? Same times, maybe this guy is also trying to download. So maybe it has block number 2 now available with it. And so on and so forth. And the whole idea is as soon as you have all the blocks, this means you have all the complete file, you're done. And you can now, your other peers now can even start downloading from you these blocks as well. All right. And then if this has all the file, this has the complete file in it. Now, what if this goes down? What will happen? No problems. The network still works. Right? Is this clear?
Yes, it's clear.
Yes, now it's clear.
So, Doctor, if I download from peer A, then he shut down his computer. The system will shift me to peer P,
Correct.
which has the same file.
Correct. Or the remaining blocks.
Yes.
And the remaining blocks. So see, if a file is very popular, what will happen? If the file is very popular, this means a lot of people are downloading it, right? This means those blocks are easily available. And as a result, the protocol will be able to get that block for you from a very close peer. All right. But if a file is very rare, like it's something which is new and it's very rare, this means it will be harder in the beginning to get it. It might be slower because a lot of people are trying to download the same thing. But the moment it becomes available in the network more frequently, you will not even notice it, and it will be available to you. So see what they've done. They've done is that they have used this P2P architecture for what it is excellent for, which is sharing content efficiently in a very scalable, robust environment. So peers can join down, okay, they can go out, so on and so forth. It will still survive. And they took out a costly process, which is all about search. So they took out the search completely from it, and they moved the searching and creation of the torrent files completely out of this application on a separate website, especially the search part. Okay, everybody's comfortable with this? Now, of course, I had this question from or someone can ask me a question. Why are we talking about this? The reason we're talking about this example is just to give you guys an perspective and understanding that how people use these styles, and they can come up and think out of the box and come up with their own solutions. The last one I'm going to show you as an example is something which is extremely popular, or which became extremely popular, or the latest version of it is the extremely popular out there in the market. And this is a completely different way of thinking, and this is a different structure completely. How many of you guys have heard about Hadoop? Anybody has heard about Hadoop?
I don't think so.
Okay. Now, again, I'm going to use this as an opportunity to A, show you an example which is very different from the ones we have seen. And B is my aim is so that, you guys at least, see a, I cannot explain and make you guys expert of this, but maybe in 5 minutes, 10 minutes, I can at least give you a bit of idea that what really happens there in a very high level, so that at least, that this is something which is there on the market and extremely popular. This is, uh, let me give you a bit of history here. So Google actually went on and created something called Google File System. And they created this Google File System to basically, help them have efficient, reliable, and easy access to data using normal commodity hardware. So they wanted to somehow come up with a solution where you don't have to purchase very heavy, expensive mainframes, huge servers. And they were thinking about a solution where, we can use simple machines, normal machines, which we purchase from Jareer or Dosri towers in Khubar, right? All these simple 3,000 reals, 2,000 real machines. They were thinking about, can we use them and replace them and come up with a structure where we can use them instead of purchasing very costly mainframes. Not every company can afford it. Even if they can afford it, it's not easy for them to maintain it, and so on and so forth. So this is how they started it, and then of course they make this public, and this next generation of this concept is called Hadoop, which is basically, an Apache open source software, and it is used for distributed storage, and of course not only storage but also processing big data. And basically it has this map reduce programming model in it as well, which allows you to go on and do a lot of processing of big data. Now, what's a big data? Big data is something, all these Facebook. Basically, Hadoop is something extremely popular in the market. Any large application nowadays which is generating a lot of data, don't be surprised. They will be using Hadoop. Facebook, Twitter, you name it, they all use this for storing distributed or distributedly storing their data, and then using the MapReduce programming model to go on and process this big data. Okay. This is again extremely popular out there in the market. As I said,
Doctor, can I ask something?
Yeah, go ahead, please.
Purchasing many cheap computers isn't it the same as purchasing one big server or expensive server?
Okay. Now, the initial cost, of course, I still believe initial cost will be still less, but the more important thing is that the maintenance is easy. That you are gonna be able to replace the ones which are failing with the new ones, because in the mainframes, in the huge servers, the challenge is that if they go down, they are very costly to maintain, to update, like IBM mainframes, main servers. They are, that's why nowadays, even you might have noticed lately, a couple of weeks ago or last week, IBM actually split themselves, and they are kind of moved away from this mainframe big server in market as well. And the reason is because of this new infrastructural concepts that's not valid anymore.
Okay, I see.
Yeah, right. So let's look at this as an example. Of course, we cannot be expert of Hadoop in 10-15 minutes, but I wanted you guys to have a vision about it. I want you guys to be able to see what's happening in the market, so that you are aware of how this big systems like Facebook, Twitter, you name it, to be honest. Anything, any place which is generating big data, which is generating data, especially unstructured data, which is not like an SQL relational database where you can have a primary key and a foreign key and attributes. No, it's very unstructured. The posts you create on a Facebook, the videos you share, the tweets you write, this is a completely unstructured data, right? And then of course you just want to also not only store this information, but you want to use it for marketing, right? That's what Facebook does. That's what Google does, right? They send you targeted advertisements. They send you targeted information. How they do it? Basically, they use this big data to process this big data, and of course it's only possible because they are using this framework, which is the latest version of Google File System. Okay, so now let's look at this as an example, just to basically very high level understand what really happens here. So what they did, they created something called chunk servers. Okay, so they introduced the concept of chunk servers. What is a chunk server? It's a normal machine, a 3000 real Jareer, or a Dosri tower machine. And what is happening here? What's happening inside it is that a file is split into a continuous chunks. That's the first thing they do. Second thing is this chunk, what they call chunk, which is a small part or a block of a file, is not very huge. So it is 16 to 64 MB. And third thing they do is that each of this chunk is replicated. So this means, there is only not one version of a copy of it. There are at least 2, 3. 3 is, I believe, the minimum. So at least 3 or more copies of this this block of the file. And of course, these replicas are stored not on the same chunk server, but they are stored on different chunk servers. Sometimes even in different geographical locations for fault tolerance. Right, so this is the first thing they did. They created something called chunk servers. They take the file, they divide it into blocks. Each block is a smaller size, and then each block is replicated, and these replicas are stored in different chunk servers. That's the first concept to understand. Second thing is they call something called master node. By the way, HDFS means Hadoop file system, Hadoop distributed file system. So they have something called master node. This master node is keeping track of the metadata. So it's just keeping track of the information, not the file, nothing, but it's just keeping track of where this file is stored on, which chunk server is stored. And of course, this master node is also replicated, so that if the original master node, the main master node goes down, the replica will kick in. Because this is critical, because this is the only place where you know where the files were actually stored, where these blocks were actually stored. And of course, you have something called client library, which is usually installed on your machine. And then you use this client library to talk to the master node to get information about the chunk server for your file. And then you connect directly to these chunk servers to access the data. So let me show you this in a more graphical way. So let's see what's happening here. These are your normal computers, 2,000, 3,000 real machines. Okay. And this is your client, the one who is storing the file or is trying to access a file. Now, this file is not stored on a local one machine. It's not stored on a one server. It's actually distributed. That's why it's called Google Distributed File System. It's all distributed now. How it's distributed is that this file is stored on, first of all, it's divided into smaller chunks or smaller pieces. And then each file is stored in a certain sequence on a chunk server, and they are also replicated, right? Now, all this information is stored on this master node. And if you're looking for a file, you will go and contact master node. Master node will say, oh, okay, you're looking for this file? No problem. Your file is stored in a certain chunk server. Go and get it from there. So you basically go and directly connect to it, get the file. What if this goes down? No problem. You have replicas. Those replicas will kick in. What if this goes down? No problem. You have the backups. They will kick in. See what's happening here?
Yes.
Yes, but Doctor, what's the benefit or advantages we got from Junk server?
Mhm.
Is it faster to download or to?
Mhm. Now, there are 2, 3 different advantages we are getting here. Now, remember, imagine with me here, this is for huge files, right? So we're not talking about small files here, right? A. B is we're talking about, these machines, these servers are simple machines, right? So we don't have a mainframe as such, right? So there are many advantages we're getting here. One advantage is, of course, you are dividing the file into smaller units, and then these units are distributed across different chunk servers, and they are also replicated. So basically, you can store this huge file in smaller parts across different servers. So the biggest problem even now, even today, is that the network bandwidth is still a big problem for us, right? Even they're planning to, they're saying we're going to move to 5G, or even on the LAN, for example, right? The biggest bottleneck for all of this is the bandwidth, right? That how much I can transfer and how fast I can transfer. So if you try to transfer a huge terabyte of data in one go, probably it will be a nightmare, right? And you will have so many failures. And if it fails, you're going to start from again from the start, and so on and so forth. So their solution is to divide these terabytes of huge data being generated into smaller parts, and then have these smaller parts stored on a normal machine. And so that even this normal machine, they are reliable enough. They work for 1 to 2, 4, 5 years. And if they go down, no problem. We'll take it out. They are all replicated. We'll take it out, bring a new machine in, update it automatically, and that's it. The strength, see why they do this. And of course, this is just a storing part. They have a map reduce programming model on top of it as well, which helps you actually do analysis on this big data.
Doctor,
Go ahead, yes.
being a simple machines, does that affect the download and upload performance?
Being a simple machine. Okay. Now again, no, it does not, because see, when we're saying a simple machine here, this means, of course, we're talking about already we're talking about i10, i7, i9, i10, right? Isn't it? So they're not that bad machines, by the way. A and B is the bandwidth download and upload is very much limited to the bandwidth you have. What kind of network connectivity you have. So and this is why they are saying, oh, we want to store terabytes of data here. These terabytes of data cannot be transported over a network in one go, or if you try to do it, it's going to be a nightmare. So that's why they are coming up with this solution.
Clear, thank you.
You're welcome. Let me monitor the chat. I have not been monitoring the chat. So the question is it a waste of storage space since we have many copies of the same file? Ah, good one. Now, say this, first of all, if you notice in a bigger picture, the cheapest thing at the moment out there in the market is the storage, right? The hard disk is, and you can have a terabytes of hard disk, and they're probably the cheapest thing out there in the market. So storage space has become relatively cheap as compared to the infrastructural costs. And B is, we need to have these replicas because if one of these machines goes down, then we want to still be able to retrieve the file, and we should be able to still go on and retrieve that specific information. So we don't want to lose files here as well. So we are willing to have a bit of a wastage, if you really want to call that way, a bit of a wastage of the storage space on to gain a benefit that we have replicas and we have fault tolerant application. Right. So in a nutshell, basically, as we said, this Google file system, or now this is, the Hadoop, it consists of multiple nodes. You at least have one master node, and you have large number of chunk servers. Each file is divided into a fixed number of chunks or blocks, so they are smaller in nature, easy to transfer over a network. These chunks or smaller parts of the files are stored on the chunk servers, and of course, each one of this chunk is how you identify them. Each one is given a unique 64-bit label, and master node does that, right? And of course, it does it, and it keeps maintaining a history and metadata about where this chunk is stored, which chunk server has it, where are its replicas. Of course, they are replicated because to have fault tolerance, and minimum is 3. Of course, for some very sensitive, large, important, critical files, chunks, they could be even, you can even have even more fault tolerance. And then, of course, you can even have next level of fault tolerance where these files are stored in chunk servers located in Riyadh, and maybe another chunk server located in Europe and US, so that they are completely in different geographical locations as well, to even kind of have you bit of fault tolerance against even natural disasters, for example, right? All right, so with this, inshallah, we have about a couple of minutes to go. Probably I'll this map reduce part, I'll inshallah, which is the last part. I will inshallah talk about this with a simple example on Sunday. Again, we cannot be an expert of this, but the idea is to help us have a bit of vision about, how industry is going on and how they really are solving different issues when it comes to, Any questions, guys? So I think everything is clear. Let me take the attendance and I'll stop the recording. And then, of course, floor is still open for questions.